Hey guys, what's up? Today I want to do like a chill stream on Bun because I've been seeing a lot of things about it and it's pretty cool. So if you don't know what Bun is, it's a JavaScript runtime bundler, like a test runner. It's got everything like mixed into it. But if you go to Jared Sumner on Twitter, then you might find like he's been doing this for quite a while, building this runtime, and it's pretty crazy. So I've been playing with it, and I thought like I'd explore it a little bit more on stream and have sort of a discussion with it or about it, and just check it out, you know. So some of the things about Bun is like the benchmarks that are coming out compared to Node and Dino is pretty crazy. In terms of like the speed of everything, and also the it's like a full, you can do npm install stuff with it, which is like twice as fast as like a normal npm install, or you can run a server with it and all those kinds of things, and that's kind of what I want to explore today. And I also want to look at tRPC compared to Nuxt, in sort of combination with Nuxt, because I haven't tried that yet. So everything on today's stream is just going to be sort of a wing it type thing and see how it goes. Might fail miserably, might be good. All right, so first of all, let's go to bun.sh, which is the homepage of Bun. We can close down Twitter, and you can see that it's a all-in-one JavaScript runtime. So you can do, basically there's also a lot of Node supported things. So you can do a lot of the Node things in Bun, but there are obviously some things that aren't supported. And if you run a Bun runtime on your PC or in a server or something, you're gonna have to have like an instance on DigitalOcean or something where you can physically install Bun with the curl command or whatever. And also it's not available on Windows, but if you do have Windows, you can just do Windows subsystem for Linux, which you will probably need Ubuntu 20 plus, because I used to have Ubuntu 18, but it kind of didn't work with that. Something to do with glib or something like that, but that's out of my realm. When it comes to kernels and things, I really don't know what I'm doing. So what I think I'm going to do is, first, I do already have Bun installed. So if you run this command, then you can get Bun installed on your system. So if you run Bun, you'll see that you get some commands. So there's the dev command, which runs a dev server. You can bundle dependencies, and it's kind of weird thing because it bundles into a node modules.bun file. So we can look at that. So let's create a directory called Bun Playground and go into that directory. And then what I'm going to do is I'm going to do an npm init -y, just so that there's a package.json. And basically you can, so let's just open this up in code, and then we can explore this a little more. All right, so we have an empty sort of folder structure here. And if you go, like, let's say you want to do index.js or ts, because Bun can run ts files. So if you just do console.log hello world, and you open the terminal and you do bun run index.ts, then it runs the code. And this seems a lot like Node, where you can just run code in files and stuff. But in the first place, this is a TypeScript file, so it's being translated like on the fly, if I'm not mistaken. And also it's not using the same engine as Node, because Node uses the V8 runtime from Chrome, and I think Bun uses JavaScript Core, which is an Apple product. So let's do JavaScript Core. So Bun's runtime is basically, when it comes to the JavaScript side of things, it's written in Zig, which is also a programming language. And Zig is pretty cool. I've played around with it as well. It's I don't know, it's really fun to write with Zig, and it's pretty fast. So JavaScript core and Zig, the two backbones of this project probably. And so when you run run a file, this isn't being sort of interpreted by a Node or V8 engine or like what we're used to seeing. It's being interpreted by the JavaScript core. So in Bun, you actually have a global called Bun, which won't work at the moment because we need a tsconfig. And I'm probably going to butcher this, so let's try and do this. So we can do compiler options, not that, compiler options, and then the lib property would be esNext, and also the module is esNext, and I think like output or target or something like target esNext, and also we need a types, which is Bun types. And so we need to install that. So we can try bun add -d bun types, which is basically like npm install or yarn add or whatever. So if we run that, it should, I mean, that was pretty, my internet connection is probably not the best in the world, but for me 2 seconds of an install is pretty great. So we can run that, and then this is giving us some issues. Let's try a reload. There we go. Okay, so now it's recognizing bun type. So now bun is a global, and bun has a few cool things that you can do, like bun.file, and let's do package.json. So let's console.log that. Oh, let's do const file equals that, and then we can do file.json, yeah, because it is a JSON file. Oops. And then we can log that. And so we can run this with bun run index.ts. Oh, that's a promise, obviously, so we have to await that. And for that to work, we have to do export nothing for some reason, which I still don't understand, but that works. So now you can see, like, we actually get like the background, I mean the package.json value we get back after running a bun.file. And I mean, it's a async process, sort of like await. We can get into await in a second, because I know there's like issues with await in Bun, but we can probably do something like promise.resolve JSON. And then we don't have to await this file.json now. We have to obviously await it to see the result, but yeah. So there's an issue with awaits. It doesn't seem like that now because it's pretty fast. But once you get into like server stuff, it makes a difference, but it's still faster than Node. So the first thing I actually want to look at is I've written two sort of packages myself, which is on npm. And I think let's start with Hyperbun probably. So we can do bun add Hyperbun. And before we actually dive into Hyperbun, let's talk about how the sort of server thing works with Bun. So in Node, you'd import HTTP and you'd create a server and you'd create sort of a handler and then you'll listen on the server. But with Bun, if you do export default like an object and you say fetch and you just return new response, which is like the web standard API, hello world. And you run this, so you can do, I think it's what, bun dev, right? Okay, so there's something happening. Okay, so now it's just doing like the file. So instead of doing that, let's do bun run index.ts. Yeah, so now it's listening. And if you open a browser and you run, it will sort of do the rendering, you know? And what I want to do firstly is just do like a basic, like this is no solid benchmark whatsoever, because to do real benchmarks you need some heavy lifting. But all I'm going to do now is write the same thing in Node and Bun and do like a request time sort of. But before I do that, let me add a package that I wrote, which is Hyperbun, which basically just wraps around all this stuff to create a router, because now obviously there's, I think, a request object coming in here, and so we can do console.log request dot something. I believe there's a request object, I'm not sure. So let's try headers probably. Refresh the page. Yeah, so you can see that there's a request object available to us, and if we type this, then we should be able to get like inference. Yeah, so if someone posts something, you can get the body with the same type of thing that you do with fetch, where you say response equals fetch, and then you get JSON back, and then you say response.json with a weight. That's kind of what this does, and you can get an array buffer, you can get a blob, which is all web standard stuff. So if you want to like convert it to Node kind of things, you have to do like buffer.from array buffer, etc. But this is like the basics of setting up a web server in Bun. Like this is all you need, and you can serve a single file or something. We can probably just do, which is crazy. Like this is a pretty crazy thing. So I'm just returning, oh, I need to do a new response obviously with the file's result. So let's see what happens. I don't even know if this is going to work, but let's see what the result is. And boom, we get the the package.json. It's pretty quick as well. I mean, if we look, this is all local, so it's not a very demanding test. But if we look at like the response times, it's like 37 milliseconds reading a file and parsing it and sending it back to the requesting client. So I think this might be a good test. So I think I'm going to do this with Node as well, and write 2 files, run one with Node and run one with Bun, and just send back the package.json and see like what's up. So, okay, so the cool thing, so I actually want to also talk about, let's just do this in vanilla, and then we can start talking about the Hono and Hyperbun. Hyperbun is something I wrote, and Hono is something much more incredible that someone else wrote, which I feel like I need to give props for, because I mean, I wrote Hyperbun very naively with just like a wrapper around the request and making it a bit more easy to build, like sort of express like syntax out. But let's first do like a little test. So let's make an index.js as well. And okay, so if I bring in a library, it's going to be a little unfair because the library needs to parse things as well. And so I need to like sort of brush up my my Node, my vanilla Node stuff. And then I think there's something called create server. Yeah, oh, obviously http.create server, and there's a listener, and this is request response, just like basic. We need the res, and then so what we want to do is get the file, so we probably need fs to get the file, and fs.read file sync, I believe, and we just want the package.json, and then what we want to do is just res.send that back. Res dot, how do I do, I'm so used to like Node type stuff, so I should probably write this to the, right, yeah, so I should probably write the file stuff. Will that work? No idea. Let's do res.end, and we should probably do encoding, right, UTF-8. I think that'll work, I'm not sure. And the port would be 3000. So let's try that. Probably not gonna work, but yeah, required. That makes sense. Okay, something's happening, so we can probably go to the browser again and just do a request. So now this is Node running because Bun is dead, and the fav icon obviously is being supplied by Bun, but I think it's been cached. Unless yeah, so the Bun server is not running, so let's just make sure. Yeah, okay, so it's dead. So let's just run Node again with index.js. Refresh. Okay, so we'll probably get close to the same response time. Yeah, so we get 41 milliseconds. Bun was like 36 or something. So, I mean, negligible difference. But let's try sort of pumping it. You know, like let's give it some work to do. And I think I'm going to use autocannon for that. And it's probably not the best thing to use. Let me just pop out the chat if somebody wants to give a shout out or something. Say what's up. Yeah, so okay, let's do autocannon. And I also believe like your benchmarking is just as good as your tool that you use. And I think I do have autocannon installed, but I'm not sure. So let's have a look. Let's close down the server. Yeah, okay, so I do have it. But I, for the life of me, do not know what the commands are to do some tests. So I just really want a basic test. So let's have a look at autocannon's documentation. Yes. Just give me like a quick example, like a CLI example. That's all I want. I don't want to read things. Yeah, okay, so autocannon's -c 100, which seems a little bit crazy. Okay, I should probably read this. Okay, so connections is C, and workers, I don't think we need to worry about workers and stuff. I literally just want like to have a basic. So -d and -p seems important. So -d is durations, default is 10, so I don't need to supply that. And -p is pipelining, the number of pipeline requests to use. Default is 1. So I guess let's just go with this example. So C100 D5 P10. So let's do that with Node first. Where did my terminal go? So let's do Node index.js. Oops. Is this the server's running. So I can just do autocannon -c 100 connections. Yeah, that's fine. And then -d was the, what was that? The duration. So let's just run it for 10 seconds, seems fine. And -p pipelining, let's do 3, I guess. And http localhost 3000. So this is basically just requesting a bunch of times to this node server. And let's get the results. So 100 connections with 3 pipelining factor, destroying my CPU at the moment. And this is what we get. Okay, so on average, 97.5% of the requests took 27 milliseconds. On the lower end, 8 milliseconds for like very few of them. 50% was 17, and then average is 16 milliseconds, which is quite good. We've made 175,000 requests in 10 seconds, and we've transferred about, on average, 8 megabytes in those requests with a standard deviation of 600 kilobytes, which is not bad. So let's go back into the Bun world, which is this, and it's basically doing the same thing. FS is reading the file, it's writing the file, it's sending it back. And there's sort of no awaits going on, nothing special, no parsing. Same thing here, it's just no awaits, just sending back the file. So I guess that's a fair comparison. So we can do bun run index.ts. So it's running, and I'm going to leave that up there so we can compare. And I'm going to do the exact same command because now bun is running on, I don't even know what server. We should probably give it a port. I think we can, right? Because yeah, it's just running on port 3000. Okay, I guess that's fine. Let's have a look at the, just make sure everything returns as it should. Okay, so we do get the file, but I mean, I didn't give them port, so probably the default is, yeah, probably the default is 3000. Okay, so let's do the same test with bun. Yeah, let's just run this. Okay, so I mean, that is something, at least. If it's not great, it is something. So if we look, let's just look at averages. So the average latency of the node request took 16 milliseconds, which is, I mean, it's so fast, like that's not going to really affect you as a human. But comparatively, Bun did average 3 milliseconds from all those requests, where like 99% of nodes requests were 30 milliseconds, 99% of Bun's requests were 9 milliseconds. And if you look at, like, this is what kind of astonishes me, like there's 175,000 requests made in Node with just the HTTP module, and in Bun there is 719,000 requests made, which is almost a factor of, probably like a factor of 6. So I don't know, I'm not going to do them all, probably 5, 6 around there. So 5 to 6 times faster. If you look at the amount of data, obviously more requests mean more data being transferred. Average 8 megabytes, average 30 megabytes, 17,000 requests per second, and basically 2,000 requests per second, which is it's a difference, you know. It's not, I'm not going to say like, going to go like out of my way saying like, oh, this is crazy, but it's a big difference. But there is something weird about this, and this is a bug I discovered. We'll get into Hono and stuff now, but I've actually tweeted Jared Sumner about this, and sorry I keep saying Summer because it just feels like I should, but So let's do a test with await. So let's say const noop equals a new promise that has a resolve, and we're going to do a set timeout of like 1 second, and we're going to do a resolve. Obviously we can probably just do this as well. Wait, yeah, like that. Okay, so that's a no op, basically just a promise that we can wait for. And then what is happening? I'm missing a, okay. So what I'm going to do is just say await noop and also make this async. And we have to obviously, okay, so basically this is going to wait 1 second, return the response, wait 1 second, return the response. And we'll do the same in Node as well. So I think I can basically just copy this. And then in this listener, we can do an async and do await. And then do the write and the end. Okay, so let's do Node first. So I'll do Node index.js. And let me clear this out. So gonna kill Node with like a few requests, probably like 100,000 or something. I should have actually left the stats up there from the previous one. Okay, so Node gets 3,000 requests in 10 seconds, which if you think about it makes sort of weird sense, because I'm supposed to await like a whole second before responding, but also like the promises eventually resolve. So I'm gonna shoot myself in the foot with this example. And now let's do Bun. Might even get a seg fault, because that does happen. Jeez. All right, see, that's what I meant about like shooting myself in the foot, but also nothing really happened. So we should probably just check how many of those responses were okay, because in Node we actually did get some data transferred, but in Bun we didn't. So I guess this isn't a fair example, because all those requests go through, but most of them aren't really valid. So we should probably just do like a single request. So let's do I guess the thing I'm trying to say or trying to prove is that as soon as there's an await in Bun's request stuff, then usually there's some sort of slowdown, and I can't think of a easy way to sort of test that now, which, because those responses were basically empty because probably nothing was sent, so it's very difficult to test. So I guess let's just move on to something else. Let's do, so I wrote 2 libraries. Let me do Hyperbun first, which is basically like a, I don't know, like a routing library. It doesn't do much. It just helps with a little bit more maintainable sort of code. So we can do bun add Hyperbun. And then also let's do npm install. Oh, we can do, I guess we can just do this. Okay, so just as an example, so that took 6 seconds to do Hyperbun and express, which is, you know, let's remove them and try it with npm. So bun remove Hyperbun and express, and then let's do npm install Hyperbun and express. Let's see what the time difference with this is. 6 seconds as well. Okay, I guess. I mean, I'm really trying not to be biased, so that's a good thing. All right, so let's delete all this, and we can do const express equals reply express. And obviously make an app. Let's do a middleware, app.use rec res next. And then on the request we'll do we'll add something. We'll say the user is sort of like John, or name John. Let's do Sally. And we can say rec.user equals user, and then we'll create a route. Console.log the rec.user and return. We don't have to return, we can say res.json hello world. Okay, so that's basically an Express app, so we can do app.listen as well on port 3000. All right, we should say next. All right, so let's see if that works. Node index.js. Okay, so it probably is running. Let's have a look at this. All right, so we get hello world, and we might as well just yeah, whatever, that's fine. Okay, so we get hello world, so that's working. And then we can do the same thing in Bun, and this is kind of how I wrote the library, which is just a puny library, so don't think anything special. So I'm going to import create server from Hyperbun. And something's wrong. Oh, wait, what? We need to do module resolution node. Okay, so now we get create server, and this returns a Hyperbun server. And then what we're going to do is say const server equals create server, and then server.get. And it's pretty, like, the typing is also, so you get delete, get, listen, middleware, patch. Oh yeah, we first need to make a middleware. So this is a little bit different. So you get a request, which is the request object, and you get the context. So context is just like any data that you want to put on there, as well as the query parameters and the sort of what do you call it, the parameters and the query parameters. So when I talk about parameters, I mean like dynamic paths, like server.get /home, or let's do /photo/id. So a query param would look like this. Context as well. So query, so you can say like const id equals, my goodness, equals the context, right? So you can access this id value off of the context dot params. Yeah. So that will be on there, and you can also do query parameters. So like, let's say you do HTTP localhost 3000 question mark hello equals the context dot query. So you get your query params and your sort of dynamic routes just as a showcase. So we'll just listen on the Sally user is equal to name Sally, and we'll say that context dot user equals user. And then over here we can use it, so we can say const user equals context, also log the user, and then in this case we can just return. So the library passes the return data as JSON, so you don't have to worry about saying create new response or whatever. But if you want to, you can still do that. So you can still say return new response and do like your own type of response. All right, so that's basically the same thing. And then down here we can do server.listen on the port of 3000. And yeah, that should be the same application. So let's do bun run index.ts and do a call and we get that back. So basically, yeah, you can kind of do the same thing in Bun than you can in Node, but obviously you need to have a instance where you have Bun installed. And there's also a kind of cool utility that I wrote into Hyperbun called as attachment. So over here, what I'm going to do is return as attachment, and then give it the package.json. And what this will do is it also expects options. Oh yeah, we need to give some file info. The name would be package.json, and the type, I guess text, I don't know, let's just return it as is. Yeah, so return as attachment that. Let's clear that out. And then we need to open a browser for this. Localhost. So if I reload, it downloads the package.json, and it happens pretty quick. Every time I reload, it's obviously going to send the package.json back. So let's do that kind of test with Node as well. And to me, so far, there's no real clear winners or anything like that, but yeah, so I'm trying not to be biased. Where's the chat? Anybody alive? No. Okay. So let's do the same thing in Node. We'll need to get a file. I guess we can just do express.static, right? Yeah. I think that'll be fine. So let's do a public folder. And then let's copy this into that public folder. And then index.js, we can clear all this out and say app.use express.static, and the root join the directory name and also public. So let's see, let's first try and get that. So this will be the same, but package.json. There we go. Oh, but it's obviously sending it back as text. So what we need to do actually, it's going to be a little bit involved, but we have to actually get the file, set the headers, I think, doesn't Express have a like as file sort of? Yeah, same file. Cool. I'm glad that. So I actually didn't have to create that folder. So let's see what happens in the browser. So we need to still do that. Join the directory name. With the package.json, and then there, I think I should do content content disposition should be attachment, and the file name should be something .json. Keep this consistent. Package, right. There we go. So it has downloaded. So now we can do that with autocannon. I don't know if it's going to work because it's sending like a binary file, but I'm pretty sure it should be fine. Famous last words. Let's try Node first. So Node index.js, autocannon that. Okay, so 29,000 requests and 21 megabytes read. Average latency 100 milliseconds and average data transfer 2 megabyte, which is fine. It's still good. And then we can. Yeah, so we're kind of doing some extra stuff here just to make this a little bit fair. Okay, so let's do autocannon again on Bun, and I cannot for the life of me remember what the node results were. So I'll just see if there's something going on in the chat. Nah, all good. Okay, so we get 192,000 requests, 763 kilobytes read. I'm not so sure about that because I mean the Node version obviously had way more data read, so I'm not sure if this is, I mean, way more requests per second, but the amount of data that's been read kind of throws me off. I mean, let's do old school. Let's go performance.now, and then I need to return something, but I also need to log the end of this. I mean, this is all kind of useless, so let's not do that. Let's explore something else, rather than try and sort of muscle up these two things to each other. I just think Bun is kind of cool, and it makes life a little easier in certain ways. Like it creates a node modules.bun, and I believe if you just do like ./node modules.bun, you get the actual code. So I'll write that to something. So let's write that to code.js, and then you have like all your code compiled into like a single file. So it can transpile or compile whatever TypeScript code, and it also gives you, like, if you look at the Bun runtime, you get like all this sort of stuff, which is kind of cool. Yeah, obviously. Read files, write Bun. You get SQL. So there's a thing called database.open, probably a file, yeah. And then db.prepare, select that from that. Bench, okay. Yeah, so basically you can have like a little local database as well. And we could do like benchmarking on that with Node.js, but seeing as my benchmarks are basically bullshit, I'm just not even gonna go down that route. But yeah, you can explore that if you want. And this is obviously some of the results that they posted. Yeah, so interesting stuff, man. Cool thing is like fetches some other things I've noticed, but on to the next thing. So let's do Hono.js GitHub. With like also the same type of thing that I built with Hyperbun, but it's really much better, much faster as well. So that they handle routes and routers. The thing is, they don't, like, usually with middleware, you know, like an array, and then once there's like so it's not like a linear middleware type thing, and they have like all these things built in, like e-tag, JWT authentication core, which is a really good job. But it's not just a Bun thing, it's also Dino, Bun, and Cloudflare workers, probably Node as well. Pretty cool. Currently, Bun does not support some function for working the application correct with Hono. JWT does not work, do not use that and play with, so I'd suggest you try that out. And then finally, I think this video had like 3 topics, so let's just make sure that we tRPC. That's quite a big one to tackle at the end of a stream, but it's more just so like I'm trying to give into the darkness. Right. So yeah, let's look at Nuxt3 tRPC. Let's see, and it's pretty cool. tRPC, and then we'll do code. Reuse this window, please. Right. So and so basically what this helps with is sort of defining API endpoints and client-side requests to this API, and it's statically typed, so not define routes, and it's a little bit different in the way, like, you can also, instead of just doing query mutation, you get middlewares and you get all sort of juicy things on there, and it's strongly typed with TypeScript from back end to front end, and you don't have any code generation. Have a look at this. I think we have to install let's follow the documentation. So we have to install let's do Bun. Let's see if Bun can help us with this. Bun add tRPC Nuxt. And then in the Nuxt config, we have to do modules. And the module would be tRPC Nuxt. This, we have to say TypeScript true, full time. I believe I am having internet sort of interface for interesting work. All right, so I'm not sure how much information was lost in the transit, but internet started giving problems and I'm not sure. Anyway, so I'm just going to keep going, and whatever gets uploaded, all the bits and bytes, that's fine. So what I was talking about is Nuxt3 and tRPC. Let's do, so if you've ever had this issue with your tsconfig giving you like issues, you have to do npx nuxi prepare, not prepared, prepare. And what that does, it generates the types for you. And this is nothing to do with tRPC, it's just the way Nuxt kind of works, because it's trying to import types from the Nuxt folder, and that doesn't exist when you first generate the project. So I think, yeah, I'm not sure if there's like a better way around that, but yeah. Okay, so what we want to look at is the tRPC thing, and I'm going to delete this bun.lock. And basically, tRPC is like similar to GraphQL, but there's no like huge schema files, and you don't have to prepare a lot of code and build it and compile and have like type inference and work with a bunch of strings and stuff like that. With tRPC, things sort of just work. So I'm going to create a server folder, but I'm actually just going to go server, and I believe we need a tRPC file and index.ts. And then we refer back to the documentation. So TypeScript needs to be true, and I'm just going to copy this, put that in there. And user model obviously doesn't create, and we also need sort. So the cool thing about tRPC is like you define input with sort of libraries. You can also create your own input validators, but it either needs to give you the thing back that it needs, or it needs to throw an error. That's kind of what like validation libraries do. So you say like, I expect a string of minimum 5, and if that's not the case, then I'm going to throw. So that kind of infers that from this, and then you can use it on the front end as well. So you don't need to use Zod. There are other libraries as well, but I'm just going to go with this example. And we don't need this infer async. This is when you want to do things on the context, which probably is a little bit out of the scope of the stream, because I feel like we're going to come to an end pretty soon, but not after like showing you the coolness that is. Hey man, thanks so much. Good luck with what? Do you mean like just good luck in general, or good luck with the stream? But thanks, I appreciate the good luck, man. You can never get enough of that. We don't need this. And what we'll do is we'll just like return an array of fake users. This user's name will be DUL Latori. Kind of cool name. And the yeah, I guess that's all we need. So that's what we'll do when we get users, and if we create user, so probably we should do this. So let's do const users equals an array, and we have like this guy or girl, don't want to assume, and yeah, then we just return the users. And then when we create a user, we'll say users.push the name would be input.name, why this? Oh yeah. So I guess, yeah, we need the input from there. And something is broken. I probably need to look at the documentation. This is why you said good luck. I get it now. So if we want to add input, oh, it's on the oh my goodness. It's on the request, so this isn't a thing. And also we need an ID. So let's create an ID for this new user. And I'm going to use Crypto's random UI ID. Something like that. And we'll need to import that, I think. Right, cool. So we can get users, and let's do another query with a specific user. And we'll resolve. And the resolve function takes a request object, obviously, and we also want to define a input on the query. So I believe you can do that, and we'll do a z.object, and we'll do id z.string. Yeah, just z.string. That's about it. And then we'll require this. Oops. So now we should have const id equals rect.input. And then with that ID, all we want to do is const user equals users, which we defined above in our little database over here. Users.find user, the user.id is equal to the ID that's been passed. Oh, please don't do this. Okay, and then we'll return the user. Right? And let's do name on this one, because we can actually just define names. Name. And that there was like a little bit of type inference. It's like ID does not exist on name string. So that's like a sort of foreshadowing on what's coming. And then user.name is equal to that name. And then that should be it. Over here we should just return something. Return the, let's give it a user. Oops. So the user that we create over here will just return back once we create them. Cool. So those are the two endpoints, and that should be it. We have like the routes set up. And now the cool thing is, if you go to, so let's do, just so Nuxt can generate its own types. But if you go to your app, now you should have everything handled for you. So you have queries, 2 queries, and 1 mutation. So now in your views or whatever, you can just do a script setup. Script, and then the way you kind of use this is you say const client equals use client, what, use oh, use async query, yeah. And the cool thing is with this you get type inference. So as soon as you sort of create like the string stuff like this, oops, it tells you like, oh, so you want to get user, do you want to get users? what query do you want? And if you say like, oh, I want to get user, and this should be an array. So okay, so that makes it a little bit better. So now you can like select the query that you want to do. So I want to get all the users, and the second argument to this is something. Oh, so the input usually goes second, but we don't have input on get user, so it's not going to suggest something. But if we do get user, it tells you, oh, you need another variable, and now it tells you, okay, so I want to do name. It tells you, okay, you need to pass a name, and that's going to be me, something like that, which is pretty cool. Okay, so we just want to get all the users, and this is just a response. So let's see what happens. So what we've done so far is just written like a server folder with a tRPC folder. We installed the Nuxt tRPC Nuxt dependency, and we've added it as a module, put TypeScript true because I think, or strict as true because there's something with the inference. And then we defined 3 sort of things in our Nuxt router, or the tRPC router. We have a query. We have a query for all the users, which we define up here. We have a query for a single user, which we find by name, and we have a mutation to create a user. So basically what I'm only doing now is just getting all the users, which is Doldolatori, and a cool name. And that's a promise object. Oh, yeah, we have to obviously await this. Oh, and because I'm in my normal working environment, I need to enable Volar for this one and disable Vitur, because I usually work with Nuxt3 as my like main day job. So obviously there's a little bit of a difference there. And Volar just helps with not, because this is a top level await, but that is supported with Nuxt3, but Volar needs to understand that. Okay, so obviously we need to check the data, and it also has a pending state, which is like use async data. So while pending, you can sort of show a loader or something, which is cool. So now we can just put the data there, refresh, and there we go. So we get this user. Let's just create a button. Add user, and we'll just like create a random user. Add click equals add user. And the way you get the client is by saying equals use client, I believe. Yeah. That might be a little bit, as a composable, that might be a little bit of a clash in name, but let's not think about that now. Okay, so we have use client, so we have the client, and we want to define add user. And what this is going to do is just going to send a request. Don't think this needs to be async. Let's do a random name. How do we get a random name? Let's do some math.random times 100 . What am I doing? Like honestly, I think there's no checking that names need to be unique, so I can just do name. And then we can do client dot mutation. So you already have like subscriptions query, and subscription is kind of cool because that's like a lot like a WebSocket. But we'll do mutation, and then it tells me create user. It also tells me that it's expecting a name, and the name would be name. So that's fine. And let's get that user back. So and this expects a name as well. Cool. So now we should be able to add users and also log that out. So if we do refresh, we get the obviously existing users, and then we do add user. It gives us a promise because we have to await this, and this needs to be async. So we really came full circle. All right, refresh. Let's add a user. So you can see it creates a user, sends it back to us. Let's add a few of them. If we refresh the page, we should see them all, which is pretty cool. This to me, it's not like I'm very excited about it in the way that that you get excited about like huge performance sort of speed type things or whatever. But I think developer experience with something like this is going to be much better, in my opinion, than even GraphQL, I would say, but mostly REST as well, because the way you do REST in Nuxt is you can define a router, but that's not completely the way you would expect it to happen. But you have to define a single file per request and do all the handlers and stuff in there. But in this case, you can even write your resolvers in different files. You can write one validation for the input of this. So let me explain what I mean here, because I think this is important. So if I create like a file called users.ts, and I say like, okay, export function create user. This is like core logic with options, and create user options as an interface. And we create that interface. And basically we don't even have to make this interface. That's kind of what I'm getting to. So if I just take this, getting a call. If I just take this, so import z from Zod, and I say, basically I want to define a schema. So this will be the schema. So const create user schema equals this. And so now I've defined a schema, but I have this type. So what I can do is just say export type create user options equals the return type of this create user schema. Actually, no, there's a better way. We can do z.infer create user schema. Right? Something like this. Type of, yeah. So now we have like our types defined in one thing. So usually you'd have to sort of define your interface separately from your schemas and then do that. So if I do options, options dot, and now it knows, like obviously I'm looking for a name because name exists on this. And the cool thing is, the way you can easily validate this now is just say const valid options, or let's say params equals create user schema dot it's called pause the options. And what this function does is it validates the input from the user towards the thing that you've defined, and then if it doesn't match that, it throws an error. So we can do z.string and give it like a error message, I believe. So let's do name must. I'm not really sure if this is correct. Yeah, so required error name is required. So this will validate against the schema, and then we'll just do return params. And then in here we can import that. So now you can define all your different core logic in different files, and then we can say import create user from users. And we already have this schema defined. So all we have to do now is just go in tRPC. We can just say, so get user probably. Input would be create user schema, which gets imported over here. And then in the resolver, we can just say return create user with the input, rec.input, because it knows like this is the type that we're looking for. So if I go back to over here now and I say get user with, it requires me to give it a name. So if I go back over here, and then say use async query, we'll just do get user. First place, it's going to tell me like, yo, I'm expecting like a name or something. And even if I try to screw it up and go name 123, it's going to tell me, yo, name has to be a string and not a number. So it's really hard to screw up with when you do things like this. And then, but obviously we're trying to break it. So let's do @tsignore. And then we try to load this. So now it's going to get user without a name. So it's supposed to give us some sort of error. And if we go to the network, oh well, that's a lot of things. So, yeah, so it's giving us an error. But the best way, I don't know if this is the best way to showcase that, but basically you get validation out of the box. But because this is so strongly typed, it's really difficult to sort of make this happen. So this is going to throw an error. So the way we can actually get this, so we can say console error and return error.message. Don't like this as error. Okay, so let's try this again. Yeah. So it's just giving like this cannot stringify arbitrary non-purchase because this was undefined. The input was undefined. So let's give it an input, probably just empty. I want to see where the request is being sent. Ah, there we go. We gave it a name. Okay, so let's do this in there, because I think this is happening on the server on load. So either we can do a, and I'm gonna leave with this, or shut down with this, is we can do this in mounted. So when we are on the client. Get data. The response would be that. This would be async. And then we want to set the data. And then obviously we want to probably console.log this data. Okay, so if we add a user, we refresh. I don't know what's happening. I'm probably doing something wrong. So this is supposed to create an error. Okay. So when I reload, I think I just had to rebuild. Yeah, the value is null. So basically it just doesn't give us the value, because when we request the user initially, we're giving an ID that doesn't exist. So when that hits this, it calls create user with, so let's do rect.input. Technically this probably shouldn't even fire. Yeah, so it doesn't, because the input has a schema, and then this schema is being validated over here as well. And then because the schema didn't match over here, I think it's not even returning anything. It's just giving us a null value because it's empty. Anyway, I think I'm going down a rabbit hole, and it's been quite a stream, so I think I'm gonna shut it off there, and then hopefully see you guys soon in the next one. This was fun. I enjoyed exploring things and messing up horribly, but my wife has been calling me for a while, so I probably need to go. Thanks so much for watching, guys. I hope you enjoyed it as much as I